It's my pleasure to introduce Soryl, who's a PhD candidate at the University of Otago Bioethics Centre and an independent researcher at More Lucid. His research interests are wide-ranging and include analytical philosophy, metaethics, animal welfare, and also wild animal suffering, which was the topic of his previous presentation on this channel. His research interests also include brain aging, sentience, and directed panspermia, and that's the topic of today's presentation. So beyond academia, Asher has been involved in the effective altruism movement. He was a researcher and outreach coordinator for the non-profit Animal Ethics. Asher is a philosophical open individualist and has a strong dedication to reducing extreme suffering, which he considers the primary goal of his life. So please join me in welcoming Asher Soryl as he shares his insights on the expected value of directed panspermia, a topic which bridges long-termist futurology, deep philosophical issues, with the ethical implications of humanity's actions on a cosmic scale. So welcome to you, Asher. It's always a pleasure to have you on the channel. And so I'll hand it over to you to begin the presentation. Many thanks.
Yeah, fantastic. Thank you. So this is a paper that has been, a long time in the works. I think 2 years ago, I was doing a visitation at Oxford University at the Uhura Centre for Practical Ethics, and there was a session or like a seminar series on animal ethics at the Natural History Museum, and I was asked to kind of just give like a basic introduction to animal ethics. And it turned out that Anders Sandberg, intellectual hero of mine, was also presenting. And so I got to meet with him, and we had a really long chat, mostly talking about wild animal suffering, like S risks, Brian Tomasick's work, which was kind of what inspired me to get into wild animal suffering as the focus of my PhD research and my master's thesis. And we started talking about directed panspermia, and I expressed, I think this is maybe the biggest or most important S risk that nobody's working on. And we held somewhat different views about it. And then he suggested, why don't we write a paper about it? Because obviously all of the best papers come from when the co-authors have a disagreement. And we've been doing that for the last 2 years amidst other projects. And I'm excited to say that it is currently under review. And so should hopefully be published soon if we're lucky. If anybody's interested in this, I can share a preprint. If you just email me, I have my contact information on the final slide. The title at the moment is To Seed or Not to Seed, estimating the expected value of directed panspermia. And I'll get into it. So in the paper, we first present on the concept of directed panspermia, discussing its history and various means through which it might be accomplished in the near future. I should also note this presentation is going to roughly correspond to the structure of the paper. I'll describe this. And then I will present on the ethical desirability of attempting it from the perspective of two common but distinct accounts of intrinsic value. And these are biocentrism and welfarism. So biocentrism roughly supports spreading life to other planets for various reasons. One reason is because it increases the total quantity of extant life. And then the second is that it reduces the likelihood of life becoming extinct. And then there are other reasons as well, which we don't focus on. But then conversely, welfarist theories oppose attempting directed panspermia because of its associated risk for creating astronomical amounts of natural suffering in the long-term future, which is contingent on the evolution of sentience and extraterrestrial kind of future biospheres. Finally, I will just briefly touch upon the expected value of attempting it, taking into consideration uncertainty about which of these two accounts is correct. So you can probably guess, based on my past or my previous presentation, kind of where I'm tending toward, which is suffering reduction. But the paper that we've written is actually arguing from an agnostic position on what actually matters. And I think there's still quite a strong argument to be made that even if you don't hold that suffering is the ultimate disvalue, that you should not attempt directed panspermia, just given uncertainty about what has intrinsic value. I'll discuss expected value, taking into consideration also the cost of waiting, and then briefly the unilateralist curse. And then we ultimately argue for a moratorium on the project. Cool. So just to start out, what is panspermia? So the Greek philosopher Anaxagoras coined the term panspermia, all in seed, for the hypothesis that life originates from tiny seeds that are spread throughout the cosmos, falling from the heavens to the earth. And then over time, this hypothesis developed in a scientific direction to explain the origins of life on Earth. So, for example, early forms of organic life might have spread to Earth via meteor impact, and while it remains somewhat controversial, the possibility of transfer of life between planets due to natural processes is taken seriously by the astrobiology community and continues to be the subject of a lot of research. So, directed panspermia instead involves intelligent actors deliberately spreading seeds, and while it was originally proposed to complement the panspermia hypothesis, implying that life on Earth might have resulted from the intentional actions of intelligent extraterrestrial civilizations, more recently the topic has been discussed as something that humans ourselves could attempt. So, over the past several decades, there have been various methods proposed to achieve directed panspermia. So, for example, in 1979, Mortner and Matloff proposed using solar sails to accelerate small payloads toward nearby stars, where they could disperse vast numbers of micron-sized capsules containing microorganisms in habitable zones where life might spread. Panspermia payloads could be engineered in various different ways to protect their stored life, such as by using small pellets containing freeze-dried bacterial spores inside water-dissoluble UV protective sheaths. And then a simple opening mechanism such as thermal expansion could release them randomly in a habitable zone without needing to use fancy electronics, which might be unreliable given the timescales and distances involved. And then more recently, in late 2022, it was proposed that you could hijack interstellar comets transiting through the solar system to convey microbial cargoes toward nearby planetary systems where they would disseminate the inoculum in their dust trails. So this would be kind of bootstrapping natural processes, kind of directed natural panspermia, if you will. Asteroids measured in the length of kilometers could be harnessed for larger scale operations as they contain liquid cores with abundant nutrients in which microorganisms can multiply. It's also been demonstrated that microorganisms could survive hypervelocity impact scenarios, again resembling natural panspermia, which makes this strategy more plausible. Basically, there are various different ways you could attempt it. And the key insight behind these projects or proposals is that even if the individual chance of a particular spore surviving the flight, encountering a suitable planet, and then successfully seeding it is minuscule, the overall probability of success can be made very large by dispersing vast numbers of spores and payloads. The probability of success also increases over time with more attempts. So today, directed panspermia appears to be increasingly plausible as a technologically viable project. So bacterial spores can survive for millions of years under protected conditions, and desiccation and freezing makes certain types of bacteria able to survive radiation doses of 140 kilograms, which is equivalent to hundreds of millions of years of background radiation on Earth. And then moreover, normal bacteria can be artificially evolved for extreme radiation tolerance, in addition to other traits that would increase their likelihood of surviving the journey intact. You could imagine further genetic modifications possible so that upon landing upon suitable exoplanets, evolutionary processes could be accelerated by a factor of like 1,000 to facilitate terraforming, eventually resulting in Earth-like ecological diversity. The Voyager probes demonstrate that even with 1970s technology, lumps of matter can eventually be sent over interstellar distances over decamillennia, and then meanwhile the Breakthrough Starshot project aims for laser-propelled nanocraft to be able to reach nearby stars within a few decades, likely capable of carrying seed payloads and potentially braked by magnetic sails. Cost of space access has also plummeted by a factor of 18 only in the last decade, making spacefaring operations increasingly affordable for non-governmental actors. So together these factors make directed panspermia a unique case to consider in the emerging field of space ethics. Because of its low profile, you can imagine weighing less than a gram for individual pansperms. Such operations could take place without the prior knowledge or consent from the international space ethics community. And then additionally, given the required velocities for interstellar delivery of microbial payloads within set timeframes, it's actually unlikely that humans would have any control over whether directed panspermia occurs once these pansperms have been launched toward their intended destinations. So the sheer scale of this project arguably trivializes conventional ethical problems that exist on our planet. If you have like a cosmic view, when you're, I guess, like projecting outward and reasoning ethically. So because of this, I think it's essential we should consider whether seeding other planets is desirable before it's been attempted. So to help clarify, the different values involved and I guess like reason about this properly, I will now consider the positions of two common accounts of intrinsic value that I discussed before, which are biocentrism and welfarism. So to begin, biocentrism is a view that holds that all and only life has ethical value. According to biocentrism, a universe containing life is always better than a universe without life, and that's because the former contains value while the latter doesn't. Two biocentric ethical views we consider in this section of the paper are life-maximizing views, which hold that we ought to increase life's total abundance within the universe, and then also life-conserving views, which hold that we should act in order to avoid the extinction of life in the universe. So we think the strongest and simplest case for attempting directed panspermia comes from the life-maximizing views, which seek to increase its cosmic abundance. Living systems require energy to function, and environments contain finite resources that can be used to produce energy. On Earth, life has existed for nearly 4 billion years, and in response to selection pressures, organisms have become exceptionally well adapted at exploiting natural resources for energy production. So habitable extraterrestrial environments also contain vast amounts of natural resources that could be exploited given enough time for evolutionary processes to take root. And here you can see just like a simple formulation of the life-maximizing argument. So we note in the paper this is a valid argument, but whether it's sound depends on the individual theorist to prove the premise is true. In the paper, we do go on to consider and critique a specific life-maximizing argument called panbiotic ethics, which is proposed by Michael Mortner. He's a notable proponent of directed panspermia. He's over the last few decades, or I think even several decades, he's actually published papers giving step-by-step instructions on how it would be achieved. I won't go into his ethical arguments in this paper. I think they're quite fraught, making an is-ought kind of fallacy. But I'm happy to discuss this in the Q&A if anyone's interested. So then next, considering life-conserving views, we note conventional applications of biocentrism tend to emphasize the importance of conservation over creation, which suggests that we might only have duties to preserve life that already exists. Spreading life to other planets might still be considered ethically permissible according to these views, but only if we're confident that they don't already have a local biota, or else we risk actively harming indigenous life forms. But if the development of life from inorganic matter turns out to be a rather uncommon event in the history of the universe, as current evidence in the search for extraterrestrial life suggests, then we might have non-consequentialist reasons for attempting it, which is to reduce the risk of life's permanent extinction on Earth. So it's important to recognize the existence of life as contingent rather than necessary, so its disappearance through some random mass extinction event, however improbable, can't be ruled out. We know that mass extinctions are fairly common on a geologic timescale, as you can see in this diagram. Of these episodes, the Permo-Triassic extinction is estimated to have wiped out over 90% of marine species and about 70% of vertebrate families on land, which is the closest the Earth has ever come to a complete extinction of all life. In the future, we might have the capacity to mitigate or even prevent certain mass extinction events from occurring. So, for example, in the past year, NASA successfully tested a proof-of-concept planetary defense system by altering the orbit of an asteroid Dimorphos by a head-on collision with a satellite, but we note this is highly sensitive to the specific cause and severity of the event, and in many other cases it seems unlikely that humans could do anything to reduce the extinction risk, even assuming that we have greatly improved technological capacities from the present. So for example, we couldn't prevent a flood basalt impacting 100-kilometer Kuiper belt objects, stars passing too close to the solar system, chaotic destabilization of the inner solar system, or the eventual red giant stage of the sun. These are things that even with like greatly advanced technologies, it doesn't seem like we'd be able to impact and reduce the risk of. So in the eventual event of Earth's complete sterilization, whatever the cause, the full extent of its badness, assuming this view, ultimately depends upon the ubiquity of life throughout the universe. So, for example, we can imagine that either of the two scenarios is true. So one is life is fairly common throughout the universe and terrestrial life is typical. And then the second is life is extremely rare throughout the universe and terrestrial life is atypical. And then in the former case, while the extinction of terrestrial life would be very bad for us, in proportion to the total amount of life in existence, it would only be mildly to moderately bad. However, in the latter case, the extinction of terrestrial life would range from being extremely bad to the single worst event in the history of the universe. Again, considering or just assuming this life-conserving biocentric take. So yeah, given uncertainty about the actual ubiquity of life, a precautionary approach would therefore support attempting directed panspermia in case of the latter scenario. So finally, we note that many conceptions of biocentrism also place significance on phenomena that emerge from life, such as biodiversity, or the development of entirely new ecosystems and biospheres. And if you consider these factors, this also makes directed panspermia more desirable. So yeah, hopefully this is like a good kind of range or just like overview of the different kind of perspectives that might support wanting to attempt directed panspermia. But moving on from that, Welfarism is a view which claims that only well-being has ethical value, and well-being is a term that in the context of philosophy refers to what is good for an individual, otherwise known as quality of life. So for the sake of simplicity, we'll assume that sentience is both necessary and sufficient for having a well-being to begin with, meaning that all and only sentient beings are legitimate subjects of well-being. I have a paper on this that's currently under review about like what are the conditions for well-being subjecthood. And even if you don't agree that it's necessary and sufficient, I think it's like minimally necessary in order to, or sentience being necessary to be a subject of well-being. So broadly, sentience refers to the capacity for an entity to have subjective experiences, meaning that they possess a unique perspective in the world or a point of view on things. And also it's like typically taken that sentient beings have the capacity to feel pain or to suffer. So unlike life-maximizing views, Welfarism doesn't necessarily imply that we should or shouldn't attempt directed panspermia, and this is because not all life forms are sentient beings. So for example, a yeast cell is living, but presumably can't feel pain. I'm happy to defend this position in the Q&A if anyone's interested. But also not all sentient beings have positive lives, such that their coming into existence directly adds value to the universe as a whole. The concept of well-being implies the existence of a value axis with two antipodal points, each corresponding to the occurrence of positive and negative states of well-being. And while in some cases it might be worthwhile to bring sentient beings into existence, this can't be assumed a priori in the same way that the creation of additional life is necessarily positive for proponents of life-maximizing views that we looked at earlier. So in other words, the desirability of a sentient being's existence is contingent upon them having a good life. So given all of this, in order to determine whether Welfarism supports or opposes direct panspermia, we would need to anticipate whether, one, the successful seeding of other planets with life would result in the evolution of sentience and therefore subjects of well-being, and then two, the quality of life of extraterrestrial sentient beings. In other words, would it be on average positive or negative? So I will get into that now. So one central concept to evolutionary theory is fitness, which is a measure of an organism's ability to successfully spread its genetic information within its environment. Because of the mechanics of genetic variation, different organisms possess different phenotypes, which describe their unique sets of physical traits resulting from the expression of their genes. And other things being equal, if a trait increases the fitness of an organism to an extent that's sufficient to compensate for its energy cost, we would model this as it becomes more likely to spread throughout the gene pool of the population, and this creates evolutionary change over time, or over the course of generations. So this process, which is natural selection, is non-teleological, even if it's directional and predictable. So the act of selection is caused by essentially whatever contributes to the correlation of a given trait with reproductive success. We assume that sentience evolved at a certain point in the phylogenetic history of life on Earth for this very reason. So while it's yet unknown when sentience first evolved, preliminary research suggests sometime very early on in the Cambrian explosion, dating back some 560 to 520 million years ago. This is actually addressed in a chapter in my doctoral dissertation, and so eventually, I will get that done this year, and I will publish that on my blog. So yeah, stay tuned if you're interested in that. But yeah, alternatively, it's been proposed that sentience first evolved during a transitional period when amphibians began to adapt to living on land some 310 million years ago in response to the newness and relative instability of terrestrial ecosystems. So this is kind of an open question. I find it more plausible that it evolved sometime during the Cambrian explosion, as I mentioned, but this is irrelevant so long as we assume that it did happen at a certain point. Exactly which taxonomic groups of animals are sentient also is an open question that's actively being debated in the literature. But current research suggests that sentience might be highly conserved across the phylogenetic history of life, or at least across different animal groups. But in any case, as I said before, regardless of where we date the first sentient being to come into existence, or which organisms we think are sentient, so long as we recognize that it did evolve at a certain stage, it follows that given sufficiently similar conditions on other planets, the convergent evolution of sentient life is a possible outcome of directed panspermia scenarios. And estimating the likelihood of sentience evolving from microbial life isn't really currently feasible given the newness of sentience in biology and other areas of inquiry. We might be able to do this in the future, but at the moment, I might have stressed in my in the last presentation that I gave, we don't even know what consciousness is, or we have a very typically very poorly defined conceptions of sentience, and so modeling under what conditions it might just naturally evolve is just not possible until we have a better understanding and we actually study this thing more. So moving on, this kind of goes over also some of the content that I discussed in the last presentation. So if you're interested in, learning more about the possible circumstances of wild animals and well-being in nature, I'd encourage you to watch that video. I think it's also on the YouTube channel. Essentially natural ecosystems contain two circumstances which are essential to consider in estimating the average quality of life of their constituents. And this is finite resources and evolutionary processes. So resource scarcity sets a natural limit on the consumption of resources in a given environment, beyond which the carrying capacity of that environment is exceeded, and not all individuals will have their energy needs met. And then evolutionary processes, as we discussed, pressure the inheritance of traits, such that organisms are better adapted to navigate these limiting conditions, ultimately in order to replicate certain molecular patterns that are common to, their lineage to future generations. So as a result of these two circumstances, we have the entirety of biodiversity on Earth, and there's significant diversity in patterns of survival and reproduction that different organisms have evolved to follow. Also, as I've kind of gone into detail in the last presentation, these have variable effects on the average welfare of individuals. So a common strategy for animals such as mammals includes investing large amounts of energy into the survival of each individual offspring, which increases their chances of reaching sexual maturity and then reproducing. So as I mentioned, all environments contain scarce resources, or at least all local environments, unless you consider the universe as a whole, which isn't really that useful for the sake of analysis. Other things being equal, increasing each offspring's capacity to exploit these resources, often in the context of fierce competition, increases the fitness of each parent because their genes are more likely to be passed on. And then animals who follow this evolutionary strategy often provide their offspring with extensive parental care, engage in eusocial or prosocial behaviors, and are well adapted to cope with rapidly shifting environmental conditions, in addition to other such survival-oriented traits. However, because these traits are quite costly, animals who adhere to this strategy often have low levels of fecundity, which describes the quantity of offspring produced by an organism over the course of their life. So all animals must reproduce in order to pass on their genes, and then consequently all animals must survive in order to reproduce. But because offspring members are genetically related to each other, not all members of the same offspring group need to reproduce in order for a given set of genes to be successfully transmitted. Only one per reproducing parent, assuming a stable population size. So this is fortunate from the perspective of optimizing for the evolutionary fitness of each parent, given how difficult it is to ensure that a given offspring survives in order to reach sexual maturity, regardless of how much support they might receive or how well equipped they are naturally to overcome challenges in their environment. And then to compensate for this risk, all animals have evolved to reproduce in excess to the carrying capacities of their environments, including humans, and the extent to which depends upon specific circumstances present within their evolutionary history. So in mammals and birds, this typically ranges in the tens to hundreds of offspring per parent, depending on the frequency of their reproductive seasons. Sometimes this can extend into the thousands, but for other animals, such as reptiles, amphibians, and fish, they can often create tens of thousands, or even up to like the millions and hundreds of millions. So it can get roughly exponential if you look at like the distribution for different taxonomic groups. These high fecundity life history strategies are just generally more adaptive across a wide variety of different ecosystems containing scarce resources, regardless of other conditions which they might contain. And then because each parent only has a finite amount of energy to invest, the number of offspring they produce is inversely related to the amount of energy invested into each offspring, and then by proxy their likelihood of survival, which constitutes the opposite trade-off to the life history strategy that humans have evolved that we considered earlier. And the plight of wild animals, if you will, is that for a population to remain stable over time, the number of deaths must be matched by the number of individuals who come into existence. So animals with higher levels of fecundity thus have correspondingly higher rates of premature mortality relative to humans or kind of lower death rate animals. Yet so long as it's statistically probable that a few offspring will survive long enough to be able to reproduce in the future, this doesn't compromise the fitness of each parent. Moreover, I would expect that just given 1,000 or 10,000 different possible permutations of natural ecosystems, whether on Earth or extraterrestrial planets that could support life, I would expect that most of them would be significantly biased toward type 3 kind of high fecundity reproductive strategies evolving. Type 1, the lower fecundity, is really only stable under very specific conditions and kind of requires it's not something that for reasons I can go into in the Q&A, it's not something I would expect would start off with or would even evolve in the lifespan of an entire planet. You really need specific conditions in order for that to be viable or competitive. So while I lack the space to assess the quality of life of such offspring, I think there are sufficient grounds to doubt that their welfare is net positive and speculate that their welfare is net negative, at least until further research has been conducted. And this is just because their lives are typically very short, and the individual animals might suffer from various conditions like starvation, malnutrition, genetic defects, parasitism, among various other causes. And then again, it's important to remember evolutionary processes are not concerned with optimizing for individual well-being, so we shouldn't expect there to be an upper limit on how bad the deaths of wild animals are to experience. We should also not expect that their baseline well-being is sufficiently high to compensate for the difficulties that they face throughout their short lives, including but not limited to the circumstances surrounding their deaths. So if it turns out that negative welfare actually does predominate positive welfare in nature, then the implications of natural suffering on directed panspermia are extremely negative from the perspective of welfarism, which is again conditional on the likelihood of sentience evolving on other planets. So not only would directed panspermia be a waste of resources that could otherwise be used to reduce suffering that already exists on our planet, but this project poses unique suffering risks, aka S risks, which are basically risks of creating astronomical levels of suffering. So it seems that Welfarism and Biocentrism are opposed on the desirability of this project. However, there is a crucial ingredient that I haven't yet considered, in this presentation so far, which is time. So, hang on, yeah. So we note that our current models of the dynamics of welfare at the level of ecosystems and biospheres are mostly theoretical. So with more time on our hands, we could work to improve our understanding of the situation, giving us a clearer picture of the possible stakes. If it turns out that natural ecosystems do tend toward a predominance of suffering, this outcome could be circumvented using future technologies. So for example, it might be possible to alter the course of evolutionary progress by creating artificial selection pressures against high fecundity reproductive strategies, or for just generally higher baseline organism welfare, which relates to what David Pearce sometimes talks about with regard to raising the hedonic set point of different humans or non-human animals. If we could implement this, then it's plausible that directed panspermia would increase the net welfare of the universe, which would earn support from welfarism. But also waiting has a cost. So if directed panspermia is a good thing, as claimed by life maximizing views, then waiting to attempt it could incur significant costs because of its astronomical scale. So this loss is compounded by the fact that the universe is in a state of accelerating expansion, reducing the size of the effectable universe by a rate of approximately 3 galaxies per year. Thus, for every year that passes in which we delay attempting directed panspermia, 3 galaxies might be permanently devoid of life for the remainder of the universe's existence. And then because galaxies contain very large numbers of planets, this loss is non-trivial. So for example, our galaxy contains an estimated 300 million planets with conditions similar enough to Earth that they're suspected to be capable of sustaining life, at least as we know it. The size of our galaxy is considered to be above average in relation to most other galaxies, which we can observe. However, galaxy sizes are roughly log normal with a median of about 400 billion stars, which suggests that the number of stars the Milky Way contains, which is 100 billion to 400 billion, might be fairly typical. For the sake of simplicity, so we're just going to do some crazy calculations, we will therefore assume that the number of potentially habitable planets within the Milky Way is generalizable to other galaxies that exist within our future light cone. And when I say future light cone, I'm referring to the effectable universe, the size of the universe that we might causally impact given the speed of light as an upper constant on causality. So this would imply that on average we lose roughly 900 million, close to a billion, potentially habitable planets annually due to the expansion of the universe. But if we assume that the velocities of microbial payloads are capped at 20 to 30% the speed of light, which is suggested by Slater and Smith, then this implies that the practical radius of our future light cone that could be affectable by directed panspermia operations is somewhere between 3.3 and 4.95 billion light years. So at most then, we're therefore only losing 1 galaxy per year due to the universe's continual expansion, which is again equivalent to 300 million potentially habitable planets. So yeah, here are some figures estimating the per year cost of delaying directed panspermia. Were such distant galaxies seeded. So 1.65 times 10 to the power of 20 billion tons of biomass, equivalent to 3.147 times 10 to the power of 19 billion tons of biomass produced annually. These are figures that I guess if you're a biocentric, then maybe this isn't like the locus of value, but this roughly approximates value. If you just want to look at the total amount or just primary production, the amount that's produced and recycled over time. However, as we noted previously, because of the velocities, we probably wouldn't be able to alter the trajectories of pansperms post-launch. So immediate action is actually plausibly required in order to prevent the creation of astronomical suffering if we're concerned with that. So to perform another calculation, O'Brien estimates that 1 billion years of existing sentient life on Earth could be equivalent to 18.2 trillion years of suffering. Importantly, he doesn't consider the possible compensatory effects of positive welfare states, but his estimate is like very conservative, and so I guess that kind of balances it out. But also at the same time, these are like, yeah, these models are like so projected so far into the future. It's very difficult to do this in a way that's like we're pretty confident that these figures hold. This just gives us like a rough idea. So if we generalize this figure to potentially habitable planets at the edge of our future light cone, the per year gain of delaying directed panspermia might therefore be equivalent to 54 quadrillion 600 trillion years of suffering that is otherwise impossible to prevent because of the expansion of the universe. So in contrast, if we take into account the actual size of our future light cone, the cost of waiting a century to spread life would be on the order of a billionth or less of the total value gained by eventual seeding. Because of this asymmetry, other things being equal, we think there's more expected value in waiting to attempt directed panspermia, at least until we have a better understanding of the nature of the problem, so that we can implement it without creating S risks. Again, the amount of potential suffering is contingent. It's not necessary, and it could be different if it was implemented properly. However, this assessment does not factor in existential risk, otherwise known as X risk, for which spreading life is likely to be the best strategy for preempting disaster in the short to medium-term future. So we note that this does not imply that a compromise can't be struck with Welfarism. So O'Brien notes that if directed panspermia is considered absolutely necessary to reduce existential risk, we could develop a system similar to a dead man's switch to ensure that seeding takes place only in the event of Earth's imminent destruction. You could call this like a life hand. So a dead man's switch is like used in, I guess, like Cold War era kind of nuclear weapons defense systems, where it's like, if you detect that another country is going to attack you, then you immediately launch nukes in their direction. So in the context of this would be like, if there's an immediate existential risk detected, then you would just immediately send out life. You could also just like reduce the likelihood of astronomical levels of suffering by maybe like, if you have pre-programmed systems only targeting planets that are like a short distance away that we could plausibly travel to, like after we've dealt with the extinction risk and actually causally impact, rather than something right on the edge of our future light cone. I think that's only relevant from the perspective of life maximizing views. But there are many different ways the system could be designed. So we could build terrestrial launch sites across different continents or use interstellar probes with the capacity to disperse seeds upon command. So, there we are. So until we have a clear strategy for implementing directed panspermia without risking the creation of astronomical suffering, because of the asymmetry, we propose a moratorium on the development of associated technologies in case that they're accidentally used. So we see a moratorium as an opportunity for actually accelerating discourse about the permissibility of attempting directed panspermia, so that it can't happen without widespread agreement between people who hold a diverse range of different values, who are interested in the long-term future, hopefully resolving existing normative and empirical uncertainties that I've outlined in this presentation. And then also, hopefully, it would increase awareness about the possibility of suffering risks that could result from space missions, which are not only limited to panspermia. So there are also like other risks, such as something that people don't often talk about is it's very difficult to actually sterilize equipment that we send to space. And even considering maybe in the next 5 years, attempts at sending future probes to Mars or even humans to Mars, we would actually just be spreading life maybe accidentally, and this could have similar suffering risks depending on the planet and the long-term future, I guess. So we do not propose a clear strategy for the enforcement of such a moratorium, which resembles a unilateralist curse scenario, both under ordinary conditions and if we had a life hand. So to briefly explain, in situations where multiple agents can perform an act, each agent has to make a private judgment under uncertainty about whether to act or not, and it's sufficient that a single agent performs the act in order to have significant effects on the world. So in such cases, the probability of at least one agent defecting approaches 1 as the number of agents increases. We note that already many objects and materials have been smuggled into space and left, including artworks, cremains, and tardigrades encased in epoxy. Satellites have also been launched without full authorization, while international laws regarding interplanetary contamination are very strict. As of the time of writing this paper, there exists little to no enforcement for breaching them, either for nation states or for private companies attempting such outer space operations. And so, yeah, actually just like, not only in the context of directed panspermia, but like just generally, we actually need a lot more coordination globally between different actors who might be, I guess like operating in space. Because, yeah, like at the moment, people kind of just do things and there's no punishment or there are no punitive measures to disincentivize those kinds of actions. So yeah, anyway, that's the end of my presentation. I have a professional website, which is ashersoryl.com, and then I have a blog, arataki.me. I'm currently looking for a job, so I just put in a hire me page if you are interested in, or if you know of somebody who might want to employ me or support me to do further research on this topic. I think, yeah, directed panspermia is like plausibly more important than AI safety, despite, almost everyone and all of the money disagreeing with this take. But yeah, precisely also because I think at the moment, panspermia isn't something that's been politicized, and as soon as a given topic becomes popular, yeah, there's a lot more money in the field, but also suddenly people have political takes on it, and it becomes a lot more difficult to enact change. Like we're kind of we have a window at the moment where we could actually plausibly enact change and create large scale cooperation, but there's just no real incentive, or few organizations seem to care about it. So yeah, or even just if you're someone that just wants to work on this, I care a lot about reducing the risk of directed panspermia. So I would just be open to collaborating. So yeah, reach out to me, and then yeah, we can have a discussion now if there's anyone in the audience with questions. So thanks.
Excellent. Thanks very much for that, Asher. Such a really interesting and engaging subject. And so I have noticed a few comments. Michael has said that he's worried that people might intentionally take microbes to Mars and in order to try and terraform it. I've also got a similar concern myself. Just for starters, have you had any interesting or just plain surprising reactions to this paper so far?
So I have had some people say it's a bit crazy that I'm including estimates about the amount of potential lost biomass. Really taking steel manning the position of the life maximizing view, for example. People would say, oh, why would you do that? Because you're kind of strengthening the case from that perspective. If someone's already sympathetic to these kinds of arguments, then maybe they're more motivated to act in the near-term future. This kind of builds upon the idea of an information hazard. I think I might have said this in my last presentation. I don't really believe in information hazards, or I think the model that one would hold or posit in order to kind of identify certain types of information as being hazardous is kind of I'm not confident that with respect to these topics that we have the capacity to model this. But what I hope is by actually steel manning this case, it kind of encourages people to take this issue seriously, and I think that by not talking about that, then it almost kind of encourages laziness of thinking oh, well, this isn't as important as this or that kind of important issue that I'm currently working on, or whatever cause area someone's happens to be prioritizing. And so yeah, I would just like to I think it's only a matter of time if we if we don't talk about it now until somebody attempts it. And also I think that people who are convinced by these arguments don't really I don't think their actions would change that much in response to these, to the estimations that I provide. People who are concerned about suffering reduction, I think this should change, their expected value calculations. and hopefully shift their cause prioritization more toward this. Yeah.
Yes, well, similar to what Michael said earlier in the comments, I'm concerned that people might want to just spread their seed across the cosmos, spread their own DNA, that is, in order just to achieve some form of perceived immortality. If it's
Yeah.
not them personally which achieves it, achieves immortality, which is highly unlikely. They might be able to achieve immortality by spreading their genes. So are you concerned, or is this a general concern, that people will want to spread their own DNA across the stars for reasons not necessarily ethically aligned, but for bragging rights, or for just wanting to say at a cocktail party, I've potentially sired billions of children who will have billions more children moving on until the heat death of the universe, to maximize copies of their personal DNA and achieve some sort of conceptual immortality?
So like acting on like a latent kind of Darwinian impulse,
Yes. Yeah. Yes.
replicating pattern. I'm not concerned about that because, as I mentioned before, like humans or like just like large low fecundity organisms that are generally adapted to survive and do the things that humans typically do. Like we require pretty like humans are actually pretty adaptive on Earth. Like obviously we have naturally spread to most continents just by ourselves without the use of modern technology. But when it comes to other different atmospheres or entirely different planetary conditions, then not even an ant would really survive. Like the concern for directed panspermia is extremely resistant bacteria, or at least the basic seeds for the evolution of organic life. But the direction or the later stages of that evolutionary process would probably look very different to the way that life on Earth is developed, and that's because, as I said, evolution is kind of each kind of consecutive generation of organisms is would be more and more adapted to the to the limiting conditions or the challenges that they would face, and different atmospheric conditions pose very unique challenges. I think just spreading human DNA wouldn't really do anything, unless of course you had bacteria that happened to maybe have contaminated the sample, and then it would be the bacteria but not the set of genes that would be passed on. So yeah.
Mm-hmm. Let's do some axiological imagineering, as you might know John Danaher, that's his phrase. If we're going to do population axiology, do you consider yourself, are you trying to maximize average well-being or total well-being? Where do your value theories lie, can I ask?
Yeah, so basically I think I don't have a strong intuition on this. I do think that the distribution scales upon which we should measure different instances of well-being are nonlinear and potentially exponential at the extremes. Yeah, so I think they're roughly nonlinear or exponential, and so we should consider a lot more seriously, I guess, instances of extreme well-being, so extreme suffering, are obviously a lot more, or according to this conception, are a lot more important to prevent than lots of instances of mild suffering, and also extreme pleasure is also plausibly far more desirable. What kind of effects these different states might have on, say, the I guess the growth or adaptability of the population is a different question. I think that being completely blissed out all of the time, or even some of the time, is probably not adaptive. Given I think valence evolved because it has computational I guess effects on allowing organisms to sense and respond to different features of their environment that are correlated with reproductive success, and being blissed out means that you don't have that kind of intrinsic motivator in order to pursue certain ends. And so theoretically I would say look for the extremes, but in practice I would just be it's probably more important to reduce extreme suffering than to try and optimize for extreme pleasure, if that makes sense.
Mm-hmm.
Yeah.
Yep. Arthur, are you ready to ask your question?
Yeah, my first question was precisely why care about average well-being and not hard valence bounds. Like it would seem much more important than we can give like hard bounds on the like negative extremes rather than just like have average high well-being. But maybe we could find some like convergence points between different axiological views and then try to like do something that's like guaranteed to be acceptable or desirable on many views. Then I wonder about the decision theoretical considerations here. If like humanity and the technological civilization on this planet ends up like seeding life outwards of life, presumably that would like increase our like probability of that having already happened, and for instance like life on Earth being the result of similarly, like I know previous iteration of life reaching the point where we have some like technological capability to do that, and that might give us a reason not to do not to do it because we don't want to live in a universe where life just like pops up, suffers horribly until it develops high enough level of intelligence in order to like start the cycle again. I'm not sure. This probably like depends on whether you're like evidentialist or like how to think about cases where we might do something that will radically alter our probabilities about pretty fundamental stuff about nature of life and the history and future of life.
Yeah, so on that point, I would say, like if we assume that our current models of physics are correct, and there was a Big Bang, and we can like roughly place ourselves within the overall history of the universe, we exist at a very early stage in what is projected to be like the total lifespan of the universe, and if you can place yourself at a very early stage, like our models would predict, then this would theoretically reduce the likelihood that we resulted from directed panspermia in this way. And so it could actually be that like maybe we came from the random event, but but everything afterwards comes from our intentional actions, which would be like pretty crazy. Like that would really be setting the conditions for the next couple of 100 billion years, or maybe even trillions of years. So there's that. And then just like secondly, kind of on the point about average well-being, I would say that like, and I think that there's kind of a tendency when we think about like the value of pleasure or the disvalue of pain, or consider the utility of different valence states of consciousness to like to look at the extremes. I think that in terms of like how sentience evolved, I think that like the function of like pain or like negatively valent states or positively valent states has to do with like just noticeable differences between like the quality of being in that state of consciousness. And it just so happens that, at least for humans, maybe this is different for different species, we seem to have settled into this like homeostasis point of room temperature consciousness. It's kind of like we can kind of bounce on one side of it, and then like experience suffering and then change our behavior, and then we kind of go back to homeostasis, or maybe we chase a kind of like desire gradient towards something that's enjoyable, but then we eventually return back. And I guess this like is related to the hedonic treadmill concept. I think that in order to preserve like the computational properties of different valent states of consciousness, all you need to do is like preserve these mappings between like negative and positive states and the kind of the resting state. And so you could like just increase the I guess the hedonic tone of an organism, so long as like like if currently it's like at 5 and then it dips down to 3 when you experience a particular painful sensation. If you raise it to 7, then it dips down to 5. But then suddenly you have like you're just at in a better state as a baseline. I think this is like a good, like maybe this turns out maybe the situation is actually different than the way that I'm portraying with this theory. But this seems like a good kind of theory just to assume for the time being, until we know more about what consciousness and valence are. yeah, preserving the I guess the functionality of valence within consciousness, and then having that, I guess, like passed on to any future generations that we might spawn as a result of panspermia activities. That strikes me as like being like a good strategy, or a good like North Star for the time being. Yeah.
You mention in the paper that there may be ways in which you can bias the likelihood of developing panspermia, which I guess catalyzes an evolutionary developmental path that involves less suffering or happens quickly. So, is the possibility of engineering these pansperms to tip the balance towards well-being rather than suffering, how feasible is it to really control evolutionary outcomes over vast and long-term processes?
So at the moment, it's not currently feasible, like technologically or even like theoretically feasible, if we're considering like hundreds of millions of years. It might be feasible in the future with new technology. I think actually our best, our hopes lie in having a better understanding of consciousness and valence, and being able to like if we have the right formalism and we can like build technologies that reliably interface with phenomenology, and I think at that point then we can start precision engineering technologies that kind of have certain impacts, reliably, either in the present, or maybe like you could imagine a technology could create an artificial selection pressure and could like modulate I guess its effect on an environment in order to kind of maintain that selection pressure as other conditions change. Maybe this could be like aided by some sort of like AI system that is like sufficiently aligned with the intrinsic value of consciousness. My claim is basically just that like it is possible in principle. It's unclear what that would look like in the present, but actually like I think the main bottleneck to the uncertainties is really just like uncertainty about like what is consciousness and what is valence. And once we've solved that, then I think a lot of other sub problems will just like naturally follow from like a solution to these like core problems that again very few people are working on. So yeah, we should just try and solve that.
Oh, absolutely, yeah. I'm so in for solving valence and solving consciousness. It just seems as though there's just so much good that could be done if we really understood the seat of experience.
Yeah.
Another question is that, like, you mentioned in the paper that there may be a way that you could encode messages inside of DNA or inside of the genome of the bacteria which you're sending across the galaxy. How would that be done? And would it actually remain intact if they evolved to a time at which they could actually introspect and read it through science?
Yeah. So that's something we can do in the present. I mean, it's not really something that like we have much of a reason to do, because it would only really be useful in the context of panspermia related activities, unless you just wanted to kind of like encode a message in, I don't know, your own genome or your dog or something like that for selfish reasons.
Yeah.
But yeah, like you could do that, and I mean, I couldn't describe the like technically how that would work. I do remember a few years ago reading a paper on this, but yeah, I would expect that like it's basically trivial, because there's just like a lot of room within like the DNA, or there's a lot of room where that isn't being used. Most of it isn't really, I think, like the result of like active selection processes. And so long as it doesn't have a deleterious effect on fitness, then at best it would just like, or no, yeah, at worst it would slightly be modified just due to random, genetic variation that occurs over like long enough timescales. But like, I'm sure there are protective mechanisms to reduce that likelihood. But also, yeah, I think probably it could be done. It's unclear. Like it would only be useful to do that if we were expecting that like we might spawn an intelligent civilization over a long enough time period, if that makes sense.
Yeah, right. We could sort of encode in a message about where not to or what not to do, where we went wrong. For instance,
Yeah, although
why we're facing down the barrel of extinction ourselves. If the expected utility of advanced mature civilization were high enough and AI was friendly enough, and it could be a long time until a few billion years into the future, from then until the end of the habitable universe.
yeah, it's also worth noting that the fidelity of information transfer via such methods would probably be like very low because what like for any given message depends equally on the preconceptions that have been internalized by the observer who reads the message. And so you couldn't just write a sentence in English. You could maybe like have some kind of proto, like maybe like based on some sort of like mathematical system that we expect would be like independently formulated across like different contexts and for different intelligent civilizations, but we wouldn't be able to like like encode like maybe we could. My suspicion is that we would only be able to like convey very basic information, because we wouldn't be able to like calibrate like our internalized reference frames for interpreting symbols and assigning meaning to them. And there's we would only be able to convey the symbols, and so yeah, it depends upon how they evolve to represent information within their experience.
Sparks from the audience is asking, do you reject Peirce's notion of information sensitive gradients of bliss?
No. So, I mean, what I was saying before about raising the, hedonic set point of different organisms would basically like build upon that idea of just like, um, like in response to a given stimulus, having like the scales shift in one direction or another, having the mapping between the just noticeable differences or the relative differences between homeostasis and a negative state or a positive state, having that difference preserved, I think would like be consistent with the information sensitive gradients of bliss kind of frame that Peirce puts forward. I think there is an upper limit to it because if you take certain theories like the symmetry theory of valence in Principia Qualia, if you take that seriously, then the higher the valence state of the organism, the less information can actually be contained within a given moment of experience. And so if you want like a very intelligent organism, or like civilization, then they have to you have to fracture or break the symmetry at least to a certain extent in order to be able to like represent differences between different points within the phenomenal character of their experience, which gives rise to like more complex comprehension of information. And so like plausibly I think you couldn't just like completely bliss max because, as I said before, like I don't you would lose any of the computational or like functional properties of valence states of consciousness, but like you could certainly raise it a lot higher than where it is currently, because where it is currently just happens to be where evolution has settled upon as like the most cost efficient solution to the problem. So yeah.
Andrew from the audience has asked, how do we know that there is not already a message in our junk DNA?
It's I guess like if I was a scientist that was like tasked with trying to figure this out, I would probably develop some sort of like ML classifier or some sort of like algorithm that just like scans like a the human genome and just looks for like regularities or looks for like symmetries that we would not expect to result from just random processes. And I expect this has probably already been done and has probably not been successful. I mean, maybe there is an ongoing debate about what kinds of patterns of information we would infer, like are the result of natural processes versus intelligent design. But yeah, like I would expect that like this this has maybe just been like attempted, but has not succeeded, at least in a way that would be like definitive, given the I've never seen a headline about like definitive proof that humans are the result of intelligent design, or that there's a message in our DNA that we can like decipher.
I'm sure people are looking. Hey, back to the idea about engineering pansperms to produce either more efficient or more happy life forms. Say we saw on Mars that there was actually a precursor to life, some early life or some basic life there. But we noticed that it was likely suffering a lot because, it was just competing over resources, and the resources were thin. But they were from a different, I guess, phylogenetic branch. I don't know if that really matters. But if we could engineer life to evolve quicker or suffer less, or evolve in some way tracking to more valuable developmental paths, should we consider directed panspermia as a means of outcompeting this other, more suffering-oriented life?
Yeah, yeah. I mean, like if we can confer like an evolutionary advantage to happy patterns of life that propagate, then maybe they could outcompete the regular ones. Although I would expect, other things being equal, that the ordinary naturally evolved patterns are probably already like the not the most adapted, but like probably more adapted than if we're just like bootstrapping these existing patterns and then just like changing a few features. Because like if it was more adaptive to raise the hedonic set points of different organisms, then evolution would have done it. I suspect there's a reason that we are where we are, and we would, in a sense, would be fighting against evolutionary processes. So we would need like an extra bit of magic in order to help us along. Like, as I said, creating artificial selection pressures. As for like suffering on life, if we discover life on Mars or something like that, my suspicion is that probably, as I said, the conditions that are required for sentience to evolve are probably like quite sophisticated. Like there was life on Earth for like hundreds of millions of years before the Cambrian explosion, and the Cambrian explosion is notable just because that was like the evolution of like predator prey kind of or co-evolution of predators and prey, and suddenly organisms needed to explicitly represent information about their environment that would allow them to like navigate their environment to flee predators or to find prey, and suddenly it became like like I think you just had like very basic modes of information processing before that, and then suddenly you needed a lot more information represented, and I think that's when sentience or conscious like bound pockets of consciousness become adaptive as a substrate for processing information or for holistic kind of computing. And I would not expect that bacteria like satisfy those conditions. It could be. I did have an interesting chat recently with Michael Johnson, who wrote Principia Qualia just a few days ago in Rome, which was fun. And he challenged me to think about the possibility of like plants being sentient. And yeah, like maybe microbes could be sentient, but this is contingent upon the physical mechanism that creates a bound pocket of experience, which is how I would define sentience, as there being boundaries between what's inside my experience and what's outside of it. If the physical mechanism to kind of create that topological pocket is actually like doesn't cost very much at all and is just like very, very simple, then maybe like maybe it's happening all over the place. At least in nature, because maybe there are just like very basic functions that this is just like the lowest energy configuration of physics in order to allow systems to perform certain functions. My suspicion is that it's a bit more, it has an energy cost, and so you actually just need you need sufficient conditions where the system has to represent quite a lot of information, like they need like locomotion, for example. And then it becomes adaptive, but probably not before that. Like I think plants probably aren't sentient because I don't think plants need a very sophisticated model of their external environment in order to, I guess like propagate their patterns, if that makes sense.
Yes, Atu has asked from the audience, how do speeds and distance scales work here? If panspermia is in some sense, a natural or probably likely outcome. Could we in the future see a universe with different panspermia waves meeting, kind of like, if different civilizations met, different panspermia waves, maybe with some protocols for handling such, if it was foreseen, and if it's possible to design the bacteria or whatever to a sufficient degree of sophistication so as to handle how to negotiate with a competing wave or an overlapping wave of panspermia coming from a different direction.
So because the size of the pansperms is so small, if the waves overlapped, like the boundaries between the waves are extremely soft, and so you wouldn't really get any interaction. They would just pass by each other. At least like if you just assume that it's a wave that is like emanating from like the point of like the civilization that sent out the pansperms. You could have that. I don't think it's the example you gave, Hansen's grabby aliens, kind of expanding bubbles of intelligent civilization. Like that would be a harder boundary because you would have presumably spaceships that are aware and have advanced sensory capacities, aware of other civilizations' expansion, and then there would be some sort of maybe conflict or meeting, or it would, this would basically just be like two meteors passing each other. But yeah, as for, it could happen, but again, it kind of depends upon, is there like a sufficient reason in order for a civilization to attempt directed panspermia? Maybe humans are just like weird in the sense that some of us decide this is like a worthwhile goal. Maybe there are plausibly, you could imagine a universe in which there are intelligent civilizations, and there is an agreed norm not to spread life in kind of this undirected random fashion. And so maybe actually if we it is possible, I'm not saying this is likely, but it is possible that we already exist in this universe and we attempt directed panspermia and then we violate the intergalactic code, and Earth gets destroyed. So maybe we should consider that as well. Yeah, but I don't know.
Given the potential for a directed panspermia to result in a suffering outcome, huge amounts of suffering as risk, what regulatory safeguards or technologically secure mechanisms do you think we could be using to mitigate the likelihood of either accidental or clandestine risks of humans trying to get panspermia out there? Or accidentally doing so. It's like some people accidentally smuggle life forms across borders in Australia and they still get in trouble for doing so.
Oh yeah, it's the same in New Zealand. If you enter New Zealand with an apple, you get a $400 fine. But yeah, as for technology, it's I don't think we could protect against it at the moment unless it was I'm not aware of sensory or sensing capacities from NASA or maybe various space kind of governance oriented institutions that we're not really actively monitoring what enters or exits. Unless it's of a sufficient size that it would just be picked up by a satellite. But if it's the size of my fist or something like that, then probably that wouldn't be picked up, is my expectation. I think maybe in the future we could have this technology. Maybe if matter passes a certain distance and its trajectory is sufficiently it looks like it's emanating from Earth rather than just passing by Earth and then maybe being propelled from the gravitational field, then maybe we could have some sort of detection mechanism with future technology. But at present, I think the best technology we have is just the ones that we evolved, which are social norms. We should just engineer, strong prohibitive norms about sending things into space without getting consent from everyone else. I think this is reasonable. We have these norms and they work in various other contexts. Fortunately, even though, as I said, the cost of space access has plummeted in the last decade, it will probably never get to the point that like anyone can just like buy their own, direct panspermia kit at home and attempt it for themselves. Like I think it will still require like quite sophisticated technology. And also, as I said before, like the likelihood of any individual attempt succeeding is very low. So maybe it doesn't matter actually that much if it has been attempted a few times before, or it's attempted with low frequency in the future. The real concern in my mind is like some sort of billionaire who is interested in space that I won't name, but I'm sure there are multiple such people that exist already. Suddenly getting this idea and being like, okay, I'm gonna allocate like 50 million toward this, and then they could probably attempt it 10,000 times because like as soon as you scale up production and you have like the equipment, or you've already purchased the equipment, it's actually trivial to drastically increase how many attempts of directed panspermia once you have like the conditions or the structure in order to attempt it once. So I would be more concerned about that, and it's kind of a good thing that still it is restricted by do you have lots of capital and do you have access to scientists and technology that would like allow you to do this. And at the moment, people are looking in different directions when it comes to, interacting with space. Like they want to do things like asteroid mining, or, things that have an obvious, profit motive. Directed panspermia is just like, it would really just be, is somebody kind of selfishly or egoistically motivated to pursue this. And that's not a sufficient reason yet, I think. Yeah.
I'm bringing in Michael Sparks from the audience who might have a question to ask.
Oh, hello. Can you hear me?
Yes.
Oh, wonderful. I was curious. You mentioned that there are already regulations preventing us from basically transferring microbes into space, but you said they were largely toothless. Do you have any strategies or thoughts on how to change that situation?
Yeah, so I mean, I think they are basically, toothless, demonstrated by the fact that there have been numerous instances of them not being heeded any attention and there being no punishment or no, kind of punitive measures taken. I think in order to, I guess, make people pay heed to them, it's, as I said before, kind of partially a matter of just getting the right norms or spreading the right norms regarding, kind of spacefaring technology. And also maybe establishing the right institutions, or at the moment there are obviously institutions that I guess on paper or nominally seek to kind of regulate activities that occur in space, but they're not none of them really come from a background of I want to say people who actually care about achieving certain objectives, and actually achieving coordination between different actors. I think that the ideal, in 10 years, my ideal future, if people started working on this issue, would be essentially get enough people who have enough influence, who work in this area, to come to an agreement. And I don't know, maybe there are multiple institutions that have similar purposes that are related to space governance. Maybe it's just one institution, but it has enough power and leeway in order to actually enact binding agreement, and also lobby for more serious measures to be taken. Because what I said before about this isn't a political issue is maybe a part of the problem, but it's also kind of it's partly a good thing that it's not political, because it means that you can change the conditions a lot easier, because as soon as something becomes political, it's very difficult to shift how things are, but also it could, if you can shift the conditions and then you can make it obviously there are demands for things to be this way or that, then I think that would be a lot better. At the moment, as I said, very few people are concerned about this, and I think you could pair direct panspermia are concerned with like a variety of other issues in space ethics, of which there are like, space ethics is like a relatively new field in philosophy and I guess like, kind of science more broadly. But it's like growing quite rapidly, and there are lots of associated issues that, the establishment of such kind of institutions could actually like, I think make like quite a, serious dent in the likelihood of certain like bad outcomes or failure modes occurring. So, yeah.
So, do you feel we're in a particularly opportune window to intervene? Like, we're right before the point where this may become politicized, but we're still at the point where it hasn't really progressed enough to be a serious, like, imminent threat. And we have a little bit of time in that space to get an organization started, get a movement going, whatever is required.
Yes, yeah, I do feel this way. Last year at EA Global London, I basically made similar arguments in this presentation and expressed this sentiment to like a variety of different like head of like directors of quite influential EA affiliated organizations that I won't name, and most of them agreed with my arguments that this is like super neglected and super important, but none of them were willing to actually like go out and do something about it. And yeah, which is unfortunate. I've also talked to like people about like maybe trying to seek funding to actually start something myself, but have not been successful because of the current economic climate. So yeah, it's I would like to see this issue being tackled, whether or not like I'm personally involved in it. I just think it's like super important, and yeah, we can actually do something about it now. Well, we might not be able to in like 10 years time.
Well, is sort of getting some traction in the media. I noticed that there's the famous science YouTuber Anton Petrov recently produced a video about directed panspermia. He didn't have any sort of ethical take on it whatsoever, but he did bring up an interesting point in that it seems as though it might be very difficult to send DNA over long distances, but where it could be bombarded by radiation. What would you say if someone were to say, hey, we shouldn't worry because it's going to die anyway? Don't worry. What would you say to try and change their minds?
Yeah, so I would say that like, yeah, probably like the longer the distance, the less likelihood of success there is, because as you mentioned, like there are lots of different conditions in space that the pansperms would have to like survive, including but not limited to kind of just background radiation. We do already have, as I mentioned at the beginning of the presentation, we already have mechanisms to deal with that. And it doesn't really like, even though I think these mechanisms are like basically sufficient if you design the pansperm correctly, even if they fail most of the time, that still doesn't really matter, because if it fails 999 out of 1,000 times, and you send out like 10 million pansperms, then that's still like a significant quantity of potential seeding of organic life in different conditions. And a lot of this is also just like made worse by the fact that now with like the James Webb Telescope, we have such advanced capacities to actually look at and detect and extract information about the atmospheric conditions on different planets. So now we can like, we could literally just like pick a planet, and even if it doesn't even look habitable from the perspective of like what are the conditions that organic life have endured on Earth, we could still like modify the bacteria and potentially have life seeded on those planets, and maybe like a very different form of life than the ones that we're used to. But this would like drastically increase the number of potentially habitable planets from the estimations that I used, which were considering like atmospheric conditions similar to Earth as kind of like a reference point.
Yes. So you talked about the trade-offs between biocentrism and welfarism, but there's a whole lot of ethical positions and a whole lot of just aesthetic positions. There's the problem of, plurality and trying to appease everybody's points of view, while at the same time you're trying to get some laws or some regulations installed to reduce the likelihood of people willy-nilly sending like panspermia off into the cosmos. How do you address the plurality problem where you need to convince a variety of people from a variety of different backgrounds so as to gain support for a strategy for reducing the likelihood of a disastrous outcome?
Yeah, so I mean, I think ultimately it doesn't matter like how many conceivable ethical positions there are. All it takes is one person who's internalized a particular, frame, who has the resources or has the means in order to do something, and then it's like, as soon as it's been attempted, we can't take it back, and so then it's just like locking the universe into this potential, unfolding of this physical process that could result in extraordinary levels of suffering, or maybe other things that are just valuable from different perspectives. I mean, I think it's actually like at the level of talking about like biocentrism and welfarism, there aren't actually that many conceptions of intrinsic value that exist that, you can deflate like numerous different ethical or like normative theories into like biocentrism as like a guiding axiology based on like where do these theories consider as like the locus of intrinsic ethical value, and then maybe the theories say different things about how we should act in response to this thing that is the locus of value. There aren't that many locuses, and the reason is that there aren't that many like things that seem resistant to deflation if you just like engage in a basic ontological analysis about like in what sense does this thing exist, and in what sense is it valuable. I think for most things that we think are valuable, you can usually like deflate them or like kind of what would the word be? You could reduce them into like what more and more closely approximates intrinsic value, and a lot of people arrive at life because for most people and for most of human history, we have seen life as a fundamental essence or a fundamental property. As it turns out, also in my thesis, I don't think life exists fundamentally. I think life is a leaky abstraction from our models of biology, and so I actually think that like my mode of ontological analysis would even deny that there is such a thing as life that could be a locus of value, because for something to be a locus of value, it has to exist in a non-instrumental sense, and I don't think that's the case with life. But all of the, this is a topic that has been discussed for thousands of years, and you can just look at the philosophy of biology literature to see that there exists no, kind of like universally agreed conception of what constitutes life. I think sentience does satisfy these kinds of conditions, and that's why also just from like phenomenological introspection, like I think any sentient being can access like insights about the inherent value of certain valent states of consciousness if they venture out in either direction. So people who have suffered or who have experienced extreme suffering and have updated their model of their normative model in response to that suffering that they've experienced do have access to an insight about, okay, this is like extremely bad. Also, if you've experienced extremely beautiful or like deep states of equanimity, like positive states of consciousness, you also have some insight about like the inherent goodness of certain states. I have experienced both, and this is basically where I've arrived at. Like I don't, but yeah, this is maybe different from the question that you originally asked, which is about kind of pragmatic like approaches to dealing with pluralism, or a plurality of different value systems. I mean, ultimately, yeah, I think that like it doesn't really matter, or it's actually intractable to find a solution if we assume all conceivable theories of value is like equally within our EV calculation. You kind of have to just like break it down to a certain point. And I think welfarism and biocentrism like are pretty close approximators for I think most ethical theories can be like reduced down to these two. So yeah.
Would you consider yourself a moral realist in the sense that, there's something real, or there are facts about the world in which we can logically point to, and we can come up with an ethical framework based on logic and facts in the real world. Or some people take it even further and say experience discloses the nature of the physical. So would you consider yourself a moral realist, and if so, what kind?
I would consider myself a moral realist, but only in the sense that I think that the actual thing that I'm pointing toward with my theory precedes logic and any sort of formal analysis. So I don't think that there are such things as facts that exist non-arbitrarily in the world. Like, I think the way that we use facts and reason and logic in order to, I guess, like model what matters is kind of secondary and is kind of arbitrary in a sense. Like, it depends upon a certain way of looking in order for these kinds of entities to exist. I think that the states that I'm pointing toward with my theory, which are the states of extreme valence, are kind of like they
They're
exist.
features.
What's that?
Well, they exist as features in the real world.
Or I don't even kind of want to like kind of label them. Like, I think you could construct a model where they're features that, or various different things, but I want to say that they exist pre-theoretically, and almost we can't talk about them like directly or in a very crisp and perfect way, because if we could completely describe them, then they would just be like facets of our semantic models of reality. And I think that, like, yeah, as I said, like, I don't think a proposition has like an inherent existence or is real in a fundamental sense, but I do think states of consciousness are, and we can kind of use language and we can use propositions to like paint pictures about states of consciousness, but we can never fully describe them. And so there's a sense in which, like, yeah, I am a moral realist because I think it is true that there are states of affairs in the universe that are better or worse from the universe's perspective or from a God's eye view. But I don't think that these states can be completely described using like, propositions or facts. And I don't think there are like truth values that apply to like the facts or the propositions that we utter that are kind of have this objective existence, if that makes sense.
Yeah, yeah. Earlier, before the talk, we were having a conversation about clean-up efforts of botched panspermia experiments, but also Arthur's actually read what he wrote. If the emergence of Darwinian life depended on currently open questions, is it just invariably an ethical catastrophe? Would it be possible to inhibit the process somehow on a cosmic scale or nudge it towards less suffering attractors, presuming that life engineered for less suffering could be evolutionary competitive, which would be one form of this, but outright sterilization or cosmic contraception or cosmic pre-implantation screening presumably requires methods unlike directed panspermia.
Yeah, so I guess that would kind of come back to what I said before about like prospective future technologies where we can actually just like create artificial selection pressures for life to evolve in a particular direction. I don't think there are ways that we could do this, like in a very like general sense. Like, I don't think you can just kind of change the universe to have a different attractor when it comes to the natural evolution of organic patterns, which is what I would define life as, is just like an organic pattern that persists through time and changes. And so, yeah, like you really have to change the conditions, or you have to have a mechanism to directly interface with the pattern itself. And both of those would require advanced technologies that we don't currently have. So we could, like, as I said before, we could have an AI system that maybe like has greatly advanced capacities in terms of like terraforming, or in terms of just like maybe like kind of keeping the gene pool in a certain way. Like maybe it kind of has like periodic releases of gene drives that kind of bias natural evolution in a particular direction. Maybe that would work. But like Yeah, we're very far away from having such capacities, and yeah, it is kind of a problem if you care about suffering reduction, because it's like, yeah, you're having to the mountain that you have to climb in order to achieve your ends is just like so much higher and so much more challenging than the mountain you have to, it's basically like a hill or just a small mound if you care about increasing the abundance of life. It's very simple. You just like send the pattern, and the pattern will unfold and achieve your end, like, in a very simple kind of like a predictable manner. But if you care about welfare, you have to like consider so many additional conditions in order to achieve your ends. And so, yeah, this is why we need more coordination and more research on this topic, I think.
If, assuming that there was funding, what would longer term research look like if it would be different?
Yeah, so I mean, what would I personally do? I would not continue publishing papers and doing like abstract philosophical work. I would like try and fly to as many like astrobiology conferences as possible, and maybe like visit as many like high profile departments. And then I would reach out to my network and my extended network, and I would try and find as many high profile individuals to talk to and to convince that they should care about this issue. And then when I have like a very large network of people who are interested and who are willing to assist, or like put their names down, and like sign like kind of like like proposal, or this often happens in science where enough scientists get together and they're like, this is important and this isn't happening, and something like that. Like once you have that kind of like that latent energy, then kind of going forth and then actually being like petitioning to much larger kind of extant institutions, while also maybe concurrently trying to establish like a secondary institution that is like explicitly concerned about like, say, S risks in space, because at the moment that's not really a thing that there isn't an existing space kind of focused institution that's concerned about S risks. And I think there could be like a lot of fruitful lobbying done, not only for directed panspermia, if such an institution exists, but establishing such an institution before, like actually like getting the support of the key players in the field is not something that I think would be very impactful. People would just write it off as like, oh, there go the EAs again, with their crazy ideas. Like, you actually need to like stimulate change from the inside. And yeah, I think I would be in a good position to attempt this, but this is just my approach. Maybe there are other approaches.
Yeah, I don't know, like lighting a fire under the need for space ethics might be useful, get people coordinated and active, but it certainly sounds like a really interesting area of research as well as important. So I'm surprised not a lot of people have really just for the sake of intellectual curiosity been looking at this in detail, which brings forth a question. Like, has this been covered in like adequately in any science fictions that you have read?
Yeah, so I mean, I think the concept of directed panspermia, if I remember correctly, originated in science fiction.
That's right, it did, yes.
Yeah, and we have a footnote in the paper.
Was it Olaf Stapleton?
Yes, I think so.
Yeah.
And yeah, so it definitely, like, I mean, as with many, kind of like real world problems that result from emerging technologies, you can usually trace and in the history of science fiction and find the seeds just sitting there. Yeah, I'm not aware of it being like actively, or like, it's not really a cultural meme yet. I mean, I'm sure you could write a good science fiction story based on it. My question would be like, why would you do that? Because then suddenly, like, the more people are interested in an idea, the more political it becomes again. And like, if you have like, thousands or like tens of thousands of fans of a directed panspermia related story online, their motivations for like holding a view are probably going to be like heavily influenced by their aesthetics, which is like related to why they find the story appealing. And so yeah, I wouldn't encourage anybody to try and make directed panspermia a cultural meme for that reason. Even in the context of like reducing S risks, I just don't think it's like, until we've like actually like even just got like a primitive structure or like widespread agreement and agreed moratorium on the development of panspermia technologies, then it just seems too risky because, as I said, as soon as something is political, then it's very difficult to actually enact changes at like a sufficiently large scale, like affecting kind of global coordination, and that seems what's really important at this stage. Like it doesn't seem like there are other solutions, to me at least, that would reduce S risk in the way that I've described.
Yeah, that's interesting. That's a really nuanced point of view too.
Yeah.
I did notice that it was covered in, I think, Kim Stanley Robinson's Mars trilogy. Well, it wasn't a directed panspermia, but panspermia, sorry, like bacteria, sort of was accidentally smuggled onto the. Well, yeah, it was just they couldn't cleanse everything really well, all the instruments that went to Mars, and it got loose on Mars, and so yeah.
Yeah. Yeah. I mean, fortunately with Mars, as I mentioned before, the timescales would be like, much longer. And so it's not really something that I expect would be a concern within like, like millions of years of human existence. Also, it's like, it's unclear, like Mars doesn't have an atmosphere, like it used to, seemingly. Like maybe once there were conditions where on Mars that could support life, because it used to have like, I think it has to do with the planet's magnetic shield, creating sufficient conditions for there to be like something of an atmosphere. But now that's not the case. And then maybe as the sun turns into a red dwarf, maybe those conditions will change again. But I expect that the window for the potential for life to sustain itself on Mars is, if it exists in the future, is probably too small for it to be like relevant in the consideration of suffering risks. Probably you need like billions of years of continued existence of a planet in relatively stable atmospheric conditions, and yeah, probably that exists outside of our solar system.
Oh, I was going to ask, do you worry that the currently dominant memeplex among those with political power leans more heavily toward biocentrism than welfare ethics?
Yes, but only to the extent that biocentrism is a more successful meme than welfarism, just in just general, kind of human culture. And I think that like the people that have that wield power in these discussions are typically like more likely to, if everybody has within a population, or most people hold a particular aesthetic just intuitively, like most people hold the aesthetic that nature is like sacred in some non-instrumental sense. This is like super common. Then the those that wield power will probably like bend to certain aesthetics that are widely internalized, just because like they want to stay in power, and it's not success. It's not worth going against the grain of kind of widely internalized aesthetics unless there's an obvious reason related to preserving your own power. So maybe that's like relevant to consider. But yeah, as I said, like it's not obvious that like the widely internalized biocentrism has like, for most people, like I actually think from talking to people, for most people they are actually against directed panspermia, because they're like, most people just kind of have this like principle of non-interference actually, about like we shouldn't interfere with other planets even if they don't have their own biospheres. There's some special value that exists, and as soon as we will contaminate it if we spread life on Earth to those planets, maybe there's some value that exists independently of that, in which case great, like this is contingently aligned with my goals as a welfarist, and so yeah, I'm like fine with that, and so long as that persists, then I wouldn't worry too much about like panspermia being too much of a cultural meme. But yeah.
Are you worried about rogue billionaires sending out panspermia missions? I mean, I imagine their capacity wouldn't be very high, but certainly something I would worry about Elon Musk doing.
Yeah, yeah. This is definitely this is the main worry I have because I think rogue billionaires probably a lot less likely to hold a principle of non-interference because usually you become a billionaire by not, internalizing that principle, and also if you just look at their actions in the present. But I'm actually worried about it because, like, I mean, it's really difficult to estimate the likelihood of success or failure, but I honestly think like 50 million, which is like a trivial sum for such a figure, 50 million might be sufficient to succeed, with like a handful of planets. And yeah, maybe like there are like unknown unknowns, and I think it's like it's prudential just to assume that like if it's possible, then it's possible, and maybe like 1 million attempts or pansperms sent in a particular direction, which if you had like the manufacturing abilities and the mechanisms to send it out, then yeah, I think like we should just assume this is possible and that it could happen. So hence needing the safety mechanisms in place.
I got a comment, and that is that Elon Musk has said that the most important thing is to keep the flame of consciousness going, even if sentient or sapient life on Earth goes extinct. So he might be inclined towards panspermia missions. Yeah, I mean, like if you were in a room with a billionaire and you had to convince them within 5 minutes, or like a minute or 2 minutes, an elevator pitch, what would be your elevator pitch in convincing people to step away from the precipice panspermia missions?
I would just say that like actions now are potentially irreversible, on very long time scales, and the relative cost of waiting, say, 50 years to attempt directed panspermia is trivial. And if we consider that like in 50 years time we might have the potential to do this in a way that is like achieves a lot more ethical objectives and doesn't have or at the very least just reduces S risk likelihood. So yeah, as I argue in the paper, I would say we don't need to do it now. We can actually just like like we can wait and we can do more research. And if you really are worried about existential risk, then create a life hand, but like design it in such a way that it's not going to go off accidentally, because like then you're scratching the itch that they're concerned about. But yeah, like as I said, there's an asymmetry with regard to that, because if we try it now, we can't, like the size of the pansperms and the velocities, like it's not plausible that in 50 years we could just like send out a laser beam and destroy them. Like it would be too difficult. Like even within like a few days, it might be impossible. So consider actions in the present are potentially irreversible in the long-term future. Yeah.
If people did really want to do it, would it be better if they only infected nearby planets within our, cosmic horizon far into the future, so that we can go and clean up afterwards?
Even like, kind of the closest potentially habitable planets, it's unclear that we'll be able to transport humans there. So I'm like, yeah, like what the cleanup process will involve is like also super unclear to me. So I'm just
Yeah.
yeah, of course it's better to do it somewhere closer if you're going to do it. Like, but I'd prefer if you didn't do it because it might still not be possible to clean up. Like these are still vast distances that we're talking about. So yeah.
All right.
Do you
Well,
believe people will target moons with liquid water first, like Io, Ganymede, Europa, for targeting pansperms in that direction? I mean, do you think that's the most reachable starting point for people who want to pursue this kind of thing?
Uh, Probably not. I think like I don't know if like within our solar system, or I mean no, actually probably like outside of our solar system. Yeah, it's like certainly there are lots of moons that might qualify as potentially habitable planets, or like at least satisfy the conditions that would be required for microbes to survive and create biospheres and whatnot. but yeah, like, I mean, I'd be more in favor of, like, you know, people trying it within the solar system if they're absolutely going to do it. But I think probably if they wanted to succeed, they would be like, oh no, this is dumb. We should just like send it somewhere where it's going to much more likely succeed. And in that case, it would be, yeah, like not Europa. But yeah, yeah.
Thanks, Michael, for that question, actually. All very good questions which you've put forward too. So thanks for attending. And also Artu and the others who have supplied questions throughout the Q&A session. Thank you very much for your contributions. And look, I'm very much looking forward to seeing where the research goes.
I feel like this was a pretty comprehensive coverage of the paper and my take on the importance of prioritizing directed panspermia as suffering risk is something that we should be doing more about, which we're not currently doing much about. So yeah, thanks for hosting.
Oh, my pleasure, absolutely. And thank you so much for spending the time to do this. I'm glad it worked out this time despite some of the technical difficulties we had last week. And thanks everybody who joined in. And if you like this stuff, please subscribe to my channel and also check out Ash's website, ashasoryl.com and arataki.me. And I'll put all the details in the description of this video. So thanks all, and peace.
Cool.